Several factors determine whether wiring is considered exposed to physical damage. These include location, accessibility, and the type of environment. Wires are considered exposed in areas where they may be subject to impact, friction, or other mechanical force. Wires that are easily accessible or visible are more likely to be accidentally damaged. Additionally, wires in areas with high moisture, corrosive chemicals, or excessive heat can deteriorate and become more vulnerable to damage. In one specific situation, a grounding wire that penetrates a wall at a low height, specifically 18 inches from the dirt, is flat to the wall without any additional protection and is not enclosed in a conduit, would be considered exposed to physical damage. Conduit provides a rigid structure that shields wires from impacts and other mechanical forces. It prevents accidental contact with the wires, reducing the risk of electrical shock or short circuits. Conduit also protects wires from moisture, dust, and corrosive substances that could compromise their integrity. Passing service inspections is crucial for ensuring the safety and reliability of electrical systems. Inspectors are responsible for identifying potential hazards and ensuring compliance with electrical codes to protect users. A grounding wire located 18 inches from the dirt and flat against the wall lacks adequate protection against physical damage, necessitating the use of conduit for safety and code compliance. The NEC, or National Electrical Code, doesn't provide a singular, universally applicable definition of exposed to physical damage. Instead, the determination relies on a combination of factors and the judgment of the electrical inspector, who considers the specific circumstances of the installation. While the code doesn't offer a rigid checklist, it does provide guidance through various articles and sections that address wiring methods and protection requirements in different environments. One must understand the underlying principles and apply them judiciously. The definition is context-dependent, varying based on the location, environment, and potential hazards present. Several key factors typically considered when assessing exposure to physical damage include the following. Firstly, location is a critical factor. Wiring installed in areas subject to impact, abrasion, or heavy traffic is more likely to be considered exposed. Examples include locations near loading docks, in industrial settings with moving equipment, or in areas where the wiring could be struck by vehicles. Secondly, accessibility plays a significant role. Wiring that is easily accessible or within reach is more vulnerable to damage. This is particularly true in public areas or locations where unqualified personnel may come into contact with the wiring. Thirdly, the type of environment is crucial. Wiring in harsh environments such as those with high moisture, corrosive substances, extreme temperatures, or excessive vibration is at greater risk of deterioration and damage. Fourthly, the height and proximity to other objects matter. Wiring installed at low heights or close to objects that could cause impact or abrasion is more susceptible to damage. The specific height that constitutes exposure isn't explicitly defined, but is generally interpreted based on the likelihood of accidental contact or impact. Fifthly, the type of wiring method employed is a factor. Certain wiring methods, like rigid metal conduit or intermediate metal conduit, provide inherent physical protection, while others, such as exposed non-metallic cable, offer less protection. The choice of wiring method should be appropriate for the environment and the level of physical protection required. Sixthly, the presence of guarding or barriers is relevant. The use of physical barriers, such as guardrails, enclosures, or covers, can reduce the likelihood of physical damage to wiring. Seventhly, compliance with relevant codes and standards, including the NEC and local amendments, is essential. These codes provide minimum requirements for wiring methods and protection based on the specific application and environment. In this situation described, a grounding wire running flat against the wall 18 inches from the ground and not protected by conduit would likely be considered exposed to physical damage due to its proximity to the ground, potential for impact or abrasion, and lack of adequate physical protection. Therefore, according to the NEC 250.32, 8. Grounding electrode conductor connection to grounding electrodes. Grounding electrode conductors and bonding jumpers shall be connected by exothermic welding, listed pressure connectors, listed clamps, or other listed means. Connection devices or fittings that depend solely on solder shall not be used. The grounding electrode conductor shall be installed in accordance with 250.64b, c, and e. 250.64b requires that the grounding electrode conductor be protected if exposed to physical damage. 250.64b protection from physical damage. Where exposed, a grounding electrode conductor or its enclosure shall be securely fastened to the surface on which it is carried. A 4 American wire gauge AWG or larger copper or aluminum grounding electrode conductor shall be protected where exposed to physical damage. A 6 American wire gauge AWG grounding electrode conductor that is free from exposure to physical damage shall be permitted to be run along the surface of the building construction without metal covering or protection where it is securely fastened to the construction. Otherwise, it shall be in rigid metal conduit RMC, intermediate metal conduit IMC, rigid polyvinyl chloride conduit PVC, reinforced thermosetting resin conduit RTRC, electrical metallic tubing EMT, or cable armor. Grounding electrode conductor smaller than 6 American wire gauge AWG shall be protected in RMC, IMC, PVC, RTRC, and or cable armor. Grounding electrode conductors and grounding electrode bonding jumpers shall be permitted to be installed in or behind building construction. The grounding electrode conductor is required to be protected from physical damage. The method of protection depends on the size of the grounding electrode conductor. If the grounding electrode conductor is 4 American wire gauge AWG or larger, it has to be securely fastened to the surface on which it is carried and protected where exposed to physical damage. If the grounding electrode conductor is 6 American wire gauge AWG, it is permitted to be run along the surface of the building construction without metal covering or protection where it is securely fastened to the construction and free from exposure to physical damage. Otherwise, it is required to be installed in RMC, IMC, PVC, RTRC, EMT, or cable armor. If the grounding electrode conductor is smaller than 6 American wire gauge AWG, it is required to be protected in RMC, IMC, PVC, RTRC, EMT, or cable armor. Therefore, the grounding wire must be protected. The NEC specifies approved methods for protecting conductors from physical damage, including the use of conduit, raceway, or enclosures. These protective measures ensure the continued integrity and safety of the electrical system. To determine whether wiring is considered exposed to physical damage, an electrical inspector evaluates the specific installation circumstances and applies their professional judgment, taking into account the factors mentioned above and the requirements of the NEC. The inspector's decision is based on a comprehensive assessment of the potential risks and the measures taken to mitigate those risks. To elaborate further on the reasons why an electrical inspector might fail an installation with an exposed ground wire, consider the following. Firstly, the National Electrical Code, or NEC, serves as the primary standard for electrical installations in the United States. While it doesn't provide a definitive definition of exposed to physical damage, it outlines requirements for protecting conductors based on their location and potential hazards. Secondly, the NEC mandates that grounding electrode conductors, which connect the electrical system to the earth, be protected from physical damage. The specific requirements vary based on the size of a conductor and the location of the installation. Thirdly, in residential settings, grounding wires are often run along the exterior of the building to connect to a ground rod or other grounding electrode. If these wires are exposed and susceptible to damage, they must be protected by conduit or other approved means. Fourthly, an inspector will consider the likelihood of the wire being struck, abraded, or otherwise damaged by normal activities such as lawn mowing, gardening, or vehicle traffic. If the wire is located in an area where such damage is likely, it will be considered exposed. Fifthly, the inspector will also consider the type of building construction and the presence of any existing protection. For example, if the wire is run along a concrete wall or behind a protective barrier, it may be considered adequately protected. Sixthly, the inspector's decision is based on their professional judgment and experience. They will take into account all relevant factors and apply the NEC requirements in a reasonable and practical manner. If an inspector determines that a grounding wire is exposed to physical damage and not adequately protected, they will typically issue a notice of violation requiring the homeowner or contractor to correct the deficiency. This may involve installing conduit, relocating the wire, or providing additional protection. In addition to the NEC requirements, local jurisdictions may have their own electrical codes and regulations. These codes may be more stringent than the NEC and may provide additional guidance on what constitutes exposed to physical damage. It is important to consult with the local electrical inspector or building department to determine the specific requirements in a given area. The grounding wire should be protected. The requirement for protecting a grounding wire from physical damage is directly related to ensuring electrical safety. Firstly, a damaged grounding wire can compromise the integrity of the grounding system, which is essential for protecting against electrical shock hazards. The grounding system provides a low impedance path for fault current to flow back to the source, causing the circuit breaker to trip and de-energize the circuit in the event of a ground fault. Secondly, if the grounding wire is damaged or severed, it may no longer be able to effectively carry fault current, increasing the risk of electrical shock or fire. Thirdly, physical damage to the grounding wire can also lead to corrosion, which can further degrade the wire's conductivity and reduce its effectiveness. Fourthly, protecting the grounding wire from physical damage helps to maintain the reliability and effectiveness of the grounding system over time. This ensures that the electrical system remains safe and compliant with electrical codes. Fifthly, the NEC mandates the protection of grounding electrode conductors to minimize the risk of damage and ensure the continued safety of the electrical system. Compliance with these requirements is essential for all electrical installations. The use of conduit or other approved protection methods provides a physical barrier that protects the grounding wire from impact, abrasion, and other forms of damage. This helps to prevent the wire from being severed, corroded, or otherwise compromised. In addition to protecting against electrical shock hazards, protecting the grounding wire from physical damage also helps to prevent damage to electrical equipment. A properly grounded electrical system helps to reduce voltage surges and other electrical disturbances that can damage sensitive electronic equipment. By ensuring that the grounding wire is intact and functioning properly, the risk of equipment damage is minimized. The requirement for protecting a grounding wire from physical damage is a fundamental aspect of electrical safety. It helps to ensure that the grounding system remains effective in protecting against electrical shock hazards and preventing damage to electrical equipment. Compliance with the NEC and other applicable codes and standards is essential for all electrical installations. The NEC doesn't provide a single, all-encompassing definition of exposed to physical damage because the determination depends on the specific circumstances of each installation. The code relies on the judgment of the electrical inspector, who considers various factors to assess the potential for damage. Firstly, the definition of exposed in the NEC generally refers to wiring that is accessible and not concealed behind walls, floors, or ceilings. However, being exposed doesn't automatically mean that the wiring is also exposed to physical damage. Secondly, the key consideration is whether the wiring is likely to be subjected to impact, abrasion, or other forms of mechanical stress that could compromise its integrity. Thirdly, wiring in areas with heavy traffic, moving equipment, or potential for contact with objects is more likely to be considered exposed to physical damage. Fourthly, wiring installed at low heights or in close proximity to the ground is also more susceptible to damage. Fifthly, the type of wiring method used can also affect the determination of whether wiring is exposed to physical damage. For example, rigid metal conduit provides a high level of protection, while exposed non-metallic cable offers less protection. Sixthly, the presence of guarding or barriers can also reduce the likelihood of physical damage. In the specific case of a grounding wire running along a wall 18 inches from the ground, an inspector would likely consider the following factors. Firstly, the height of the wire above the ground makes it vulnerable to damage from lawn mowers, weed whackers, or other landscaping equipment. Secondly, the wire could also be damaged by contact with vehicles or other objects. Thirdly, the lack of any physical protection, such as conduit or a protective cover, further increases the risk of damage. Based on these factors, an inspector would likely determine that the grounding wire is exposed to physical damage and requires additional protection. The NEC provides specific requirements for protecting grounding electrode conductors from physical damage, depending on their size and location. These requirements typically involve the use of conduit, raceway, or other approved protection methods. It's important to know that the determination of whether wiring is exposed to physical damage is not always clear-cut and may depend on the interpretation of the electrical inspector. Therefore, it's always best to consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and standards. The primary goal of protecting wiring from physical damage is to ensure the safety and reliability of the electrical system. Damaged wiring can pose a serious risk of electrical shock, fire, and equipment damage. Compliance with the NEC and other applicable codes and standards is essential for protecting against these hazards. The specific location and environment significantly influence the determination of whether wiring is exposed to physical damage. The proximity of the ground wire to the earth, being only 18 inches away, presents several potential risks that necessitate the use of conduit for protection. Firstly, lawn care equipment, such as lawnmowers and weed whackers, poses a direct threat. These tools can easily strike the exposed wire during routine lawn maintenance, causing damage to the insulation or even severing the conductor. This is especially true if the wire is not clearly visible or is located in an area where landscaping is frequently performed. Secondly, the wire's low position makes it susceptible to accidental contact from other sources. Children playing, animals, or even adults may inadvertently kick, step on, or otherwise disturb the wire, leading to damage over time. This is particularly concerning in residential areas where foot traffic and outdoor activities are common. Thirdly, environmental factors can also contribute to the risk of physical damage. The wire's proximity to the ground exposes it to moisture, dirt, and debris, which can accelerate corrosion and degradation of the insulation. Additionally, temperature fluctuations and exposure to sunlight can cause the wire to become brittle and more susceptible to cracking or breaking. Fourthly, the absence of conduit leaves the wire vulnerable to impact from falling objects. Rocks, branches, or other debris can strike the wire, causing damage to the insulation or conductor. This is especially relevant in areas with trees or other vegetation. Fifthly, the lack of physical protection makes the wire an easy target for vandalism or tampering. Exposed wires can be tempting for children or others to pull, cut, or otherwise damage, leading to potentially dangerous situations. Given these risks, it is clear that the ground wire's location 18 inches from the ground necessitates the use of conduit to provide adequate physical protection. The conduit acts as a barrier against impact, abrasion, moisture, and other environmental factors, ensuring the long-term safety and reliability of the electrical system. The conduit should be properly sized and installed according to the NEC and local codes to provide the necessary level of protection. Additionally, the conduit should be securely fastened to the wall and grounded to prevent electrical hazards. The requirement for conduit in this situation is not merely a matter of aesthetics or convenience, it is a critical safety measure that protects against potential hazards and ensures compliance with the electrical codes. Ignoring this requirement can lead to serious consequences, including electrical shock, fire, and equipment damage. The fact that the wire is flat against a wall, without any additional protection, further increases its vulnerability to physical damage. When a wire is flush against a surface, it becomes more susceptible to being pinched, crushed, or abraded. This is because any external force applied to the surface is directly transferred to the wire, without any cushioning or buffer. The absence of a gap or space between the wire and the wall eliminates any opportunity for the wire to flex or move slightly in response to external pressure. This can lead to stress concentrations and premature failure of the insulation or conductor. Additionally, the wire's close proximity to the wall makes it more difficult to inspect and maintain. It may be challenging to visually assess the condition of the wire or to detect any signs of damage or deterioration. This can delay the identification of potential problems and increase the risk of electrical hazards. Furthermore, the wire's flat position may make it more likely to accumulate dirt, dust, and moisture, which can accelerate corrosion and reduce its lifespan. The combination of the wire's low height and its flat position against the wall creates a particularly hazardous situation. The wire is not only exposed to potential impact and abrasion from external sources, but also lacks any inherent protection due to its close proximity to the surface. To mitigate these risks, it is essential to install the wire in conduit, which provides a rigid and protective barrier. The conduit should be properly sized and installed to ensure that the wire is adequately protected from physical damage. Additionally, the conduit should be securely fastened to the wall to prevent it from being dislodged or damaged. The conduit should also be grounded to prevent electrical hazards. In addition to conduit, other protection methods may be used in certain situations. For example, a protective cover or guardrail can be installed to prevent accidental contact with the wire. However, these methods may not provide the same level of protection as conduit, particularly in areas where the wire is exposed to significant physical stress or environmental hazards. The decision to use conduit or another protection method should be based on a careful assessment of the specific risks and the requirements of the NEC and local codes. It is important to consult with a qualified electrician or electrical inspector to ensure that the chosen protection method is appropriate for the application. The installation of conduit or other protection should be performed by a qualified electrician in accordance with all applicable codes and standards. This will help to ensure that the electrical system is safe, reliable, and compliant with regulations. Electrical inspectors play a crucial role in ensuring that electrical installations meet safety standards and comply with the NEC and local codes. Their primary responsibility is to identify potential hazards and ensure that they are properly addressed to protect people and property from electrical shock, fire, and other risks. When an inspector fails an installation, it means that they have identified one or more deficiencies that must be corrected before the installation can be approved. These deficiencies may involve violations of the NEC local codes or accepted industry practices. The inspector's decision to fail an installation is not arbitrary or personal. It is based on their professional judgment and experience, as well as their knowledge of electrical codes and safety standards. They are trained to identify potential hazards and to assess the level of risk associated with each deficiency. When an inspector fails an installation, they will typically provide a written notice of violation, which outlines the specific deficiencies that must be corrected. The notice may also include recommendations for how to correct the deficiencies and the deadline for completing the repairs. It is important to take the notice of violation seriously and to address the deficiencies as soon as possible. Failure to do so can result in further penalties, such as fines or legal action. In some cases, the inspector may require that the electrical service be disconnected until the deficiencies are corrected. When correcting the deficiencies, it is important to hire a qualified electrician who is familiar with the NEC and local codes. The electrician should carefully review the notice of violation and develop a plan to address each deficiency. They should also obtain any necessary permits before starting work. Once the repairs are complete, the electrician should contact the inspector to schedule a re-inspection. The inspector will review the repairs and verify that they meet all applicable codes and standards. If the repairs are approved, the inspector will issue a certificate of compliance, which indicates that the installation is safe and compliant with regulations. If the repairs are not approved, the inspector will provide additional feedback and may require further corrective action. It is important to work with the inspector to resolve any remaining issues and to obtain a certificate of compliance as soon as possible. Failing an electrical inspection can be a frustrating experience, but it is important to remember that the inspector is acting in the interests of safety. By addressing the deficiencies identified by the inspector, you can help to ensure that your electrical system is safe, reliable, and compliant with regulations.